In today's world, our applications need to be capable of running in many different environments. Depending on what environment we are currently in, we may need different configuration settings to be used in order to start up or run our application properly. For example, if you are running our application in our local environment, we may rely on specific database credentials, valid only for our local database instance. The same goes for our production environment, which should have a completely different set of database credentials. It's a common best practice in the Node.js community to store these configuration variables as a part of the environment in the Node.js global process env object. To help us utilize this global process env object in a more automated fashion, Nest provides us with a package called Nest.js config, which has several useful features that we'll showcase in the next few lessons. Let's get everything set up in our application to see it in action. If we head over to our terminal, let's type in npm install nest.js config. We'll continue ahead as we already have it installed, but if you are following along, just pause the video and come back when it's finished. Once the installation is complete, let's open our app module file and add config module from nest.js config to our imports array. Now, let's call the forRoot static method on it, which will load and parse our env file from the default location, which is our project's root directory. The config module is also going to merge key value pairs from the env file with environment variables assigned to process env, storing the result in a private structure that we can access anywhere in our application via a config service class. More on that in a moment. But wait, what is this .env file? We don't have one in our application. In Node.js applications, it's common to use env files to hold key value pairs of important application configuration data, whether they are secret keys, database options, passwords, etc. With the help of these env files, running an app in different environments just becomes a matter of swapping in the correct env file. So let's create our first .env file in our project's root directory. Open up this file and let's add a few configuration key value pairs. As you can see, all the variables we defined are related to our database configuration, with their values taken from our Docker Compose file. Since all these values will vary by environment, this is exactly why we want to take advantage of something like this env file instead of hard-coding these configuration values in our application's code. Always remember that env files with real credentials and secret keys should never be tracked by Git. To make sure that env files won't be pushed up to our repo, let's open up our gitignore file and add the following lines. With this in place, let's open up the app module again and update the options object passed into the typerem module, and start to leverage these environment variables we just provided, replacing those previous hard-coded values. Note that by default, every value that comes from process env is a string. This is why we are getting an error for database port, but if we cast it to a number by adding a simple plus before it, we are all set. Now, let's fire up the app in development mode with npm run start dev. If we look carefully, we should see typerem module dependencies initialized. Just like before, we successfully established a connection to our Docker Postgres database, but now we are using the configuration loaded from our current environment. By default, the config module we've set up in the previous lesson looks for a .env file in the root directory of our application. To specify another path for this file, let's pass in an options object into the forRoot method and set the env file path property like so. In this example, we are looking instead for a .environment file. We could also specify multiple paths for .env files by passing an array of strings instead. Just know that if the same variable is found in multiple files, the first instance found takes precedence over the rest. When deploying your application to a production environment, you may not need a .env file since you may be setting all of the configuration variables via your provider UI, let's say for example, Heroku or something similar. In that case, you have the option to entirely disable loading env files by simply adding ignore env file in your config module options. And just like that, your env file will be ignored by the config module entirely. Environment variables we set are essential to our application starting up and running properly. Since our application depends on them, we need to make sure that we have all the required variables we need, so we can connect with the correct databases, etc. It is a best practice to throw an exception during application startup if any required environment variables have not been provided or if they do not meet certain validation rules. The Nest.js config package lets us take advantage of the Joey package to make sure any important environment variables are validated. With Joey, you can define an object schema and validate JavaScript objects against it. To get started with Joey, let's install a few packages. For our regular dependencies, we'll need Happy Joey. For our dev dependencies, we'll want to make sure we have types Happy Joey for all type declarations. We'll continue ahead as we already have these packages installed, but if you are following along, just pause the video and come back when it's finished. Now that everything is installed, let's define our first Joey validation schema. Inside of our config module for root method, we have the validation schema property available to us. Let's use that to ensure certain environment variables are passed in and in the correct format. Let's put all of these variable tests inside of Joey object. Make sure that Joey object is imported from the Happy Joey package. By default, all schema keys are considered optional. But you can see here we are marking database host as required using Joey required, and for database port we are setting a default value if none is passed in and requiring that it must be parsable to a number. Now, let's fire up our terminal to see if everything works properly so far. Great! Since we have both variables defined, the application still bootstrapped successfully. Now let's open our .env file and just for testing purposes, remove the database host line and save our changes. Note that to trigger Nest application reload, we must save a TypeScript TS file. The Nest CLI does not watch for changes in env files by default, so just go ahead and open any TypeScript file in our source folder and hit save to trigger our recompilation. If we head back to our terminal, we can see the config validation error appeared in the console as expected, since we didn't provide the database host. It looks like our validation is set up perfectly. Although we just barely scratched the surface here, you can see the potential in this type of validation, especially with large configuration sets. The config module we've set up in our application comes with a useful service called config service. This service provides a get method for reading all our parsed configuration variables. Just as we use any other provider in our Nest applications, to inject the config service, we must first import its containing module, the config module, into any module that needs to use it. To demonstrate this, let's open up the Coffees module and import the config module here. Remember, we used forRoot method in our main app module, but we only do that once. Here, we won't need to do anything else. Now, let's navigate to the Coffees service file and inject the config service imported from Nest.js config into the constructor. As we were saying a moment ago, this config service provides a get method for reading configuration variables. You can get a single environment variable by passing the variable name. To test it out, let's add the following code in our coffee service constructor. Note the type argument string. It instructs TypeScript that we expect a string value here. However, it's just information for the compiler. Even if we specify number instead, the real value will be string. Remember that every environment variable is a string by default. The config service will not perform any typecasting or parsing here, so make sure you are doing any type conversions necessary with these variables. Alright, let's fire up the terminal and look to see if the console outputs anything. Great! We can see that localhost got locked in our console. The get method also takes an optional second argument, which allows you to set a default value to be used if the key does not exist. Now, even if we don't set database host, our application will fall back to the value localhost. This is extremely helpful in setting some sane defaults in our application in situations where some environments may not pass all the key values we need. For more complex projects, we may need custom configuration files to return nested objects. These custom config files can allow us to group related configuration settings by business domain. Let's say, for example, that we want to group all of our database related settings together. This gives us the ability to store related settings in individual files and manage them independently. For demonstration purposes, let's create a new file named appconfig in the source config directory, which we'll use to represent our global application configuration. In this newly created file, let's export a factory function that returns a configuration object. The configuration object can be any arbitrarily nested plain JavaScript object. The process env object will contain the fully resolved environment variable key value pairs from our .env file. Since we have full control of the return configuration object, we can add any required logic to cast values to appropriate types, set any default values needed, anything we would like. In our example here, you can see that we specified an object with two properties, environment and database. The environment string represents the current environment, while database is an object that has host and port properties, grouping any configuration related to our database connection here. As you can see, we are parsing database port to a number, as every process env variable is a string by default. And we even set up a fallback value port in case none was provided. So how can we utilize this new configuration file we created? If we open up the app module and look at our config module for root again, we can pass in a new property called load, which takes in an array of configuration factories. Inside this array, we can pass in our new app config, making sure to import it from the correct location, and we are all wired up. Great! So how can we access this appconfig object from within our classes now? Well, we can actually use the config service from the previous lesson. The get method not only allows you to retrieve the environment variable by key, but it can also traverse a nested custom configuration object we created in our custom config file. Let's open up the coffee service file and update our code to use it. Let's remove the string database host that is the name of the .env file key and access our custom configuration object instead by entering database.host. While we are at it, let's also remove the string type assertion since it is a default type anyway. Alright, let's fire up the terminal and check to make sure our application still runs properly. Perfect! We can see the localhost log is still showing up in our console. But how did this work? When we pass database.host to the config service get method, this dot notation naming format is in fact a path to our host property. If you look at the appconfig file again, you will see this object. To access the host property, we need to traverse this object and pass in the dot notation name you would use to access it normally in JavaScript. While this approach is acceptable for relatively simple configurations that do not have large deep nested structures, this might quickly become unmaintainable for complex configuration object hierarchies. This is because with this approach, there is no type inference, and we keep entering magical strings to access these values, which can potentially lead to more errors just from a small typo. For more sophisticated structures, we'll use another feature called configuration namespaces in the next lesson that help tackle some of these shortcomings. The config module allows us to define and load multiple custom configuration files with nested objects and access these variables via the provided config service. But what if our application grows tremendously and we have a very complex project structure? We may need feature-specific configuration files located in multiple different directories. As we have more and more configuration keys, getting all of the config values using the untyped get method can be quite error-prone, since we have to use dot notation to retrieve nested items. To prevent this from happening, let's combine two techniques: configuration namespaces and partial registration to future-proof our configuration setup. First, let's create a new config directory within the coffees folder. Inside this directory, let's create a new file named coffees.config, which we'll use to represent configuration specific to the coffees module. For demonstration purposes, let's add a configuration foo equal to bar. One key difference compared to our app config we've created in the previous lessons is the use of the register as function here, which was imported from Nest.js config. This register as function lets us register a namespace configuration object under the key passed as our first argument, which in this case is coffees. Alright, with this in place, let's open up the coffees module file and register this coffees config using the config module for feature method. This technique is called partial registration. Thus far, we've processed configuration files in our root module with the forRoot method. As your application grows, you may end up with several feature-specific configuration files located in multiple different directories. Rather than loading all of these files in the root module, the config module allows you to register them close to their domain. Let's move on to the coffees service constructor definition now, and use the config service to retrieve these feature level configurations. To get the coffees config object, let's use the get method again, this time passing in our partial registration name of coffees. Also, let's change the variable name to coffees config. Now, let's fire up our terminal and see what got logged in the console. Great! It looks like the entire coffees config object was logged back to us, which is perfect. We can access specific properties of this partial config, just like we did before, using dot notation again. Now, we'll retrieve the specific foo value and get bar. Using the config service get method is a generic way of accessing various configuration properties registered within your application. It comes in handy while getting .env variables, or when you need to interact with many different configuration objects at once in a single service. But here, we are using that string dot notation again. We still don't have full type safety when we retrieve nested properties, and we know how error-prone that could be. Not only that, but this approach makes testing more difficult, because we would need to mock the get method, hardcode environment logic, and return different values based on different keys. So what's the ideal alternative? When dealing with these configurations, It is a best practice to inject the entire namespace configuration object directly. Each namespace configuration exposes a key property, which we can use in order to inject the entire object to any class, register it within the nest container. In addition, the config type is a helper type provided out of the box, which infers the return type of our function. Now, we can access this object directly instead of using the get method. We even have the benefit of strong typing now. No more dot notation, no more magical strings, and hopefully no more errors. Now the compiler will warn us anytime we try to use a property that does not exist, or if we mess up any of the types. As we learned in previous lessons, dynamic modules, such as the TypeORM module, can be configured by consumer modules by calling static methods and passing the options as arguments. For example, in our application we are calling the TypeORM module for root method to specify database connection options for TypeORM. In this code here, we've used the process_env object to extract the environment variables loaded by the config module we imported above. But what happens if we move the TypeORM module for root lines inside our imports array so that it is above the config module for root call? Let's try it real quick, save our changes, and open up the terminal. Surprisingly, it doesn't work now. Our application is throwing an error because our process environment variables are being loaded after the TypeORM module for root call happens. Thus, all these values, database host, database port, etc., will fall back to undefined. It is a best practice for our applications to always be deterministic. The module's import order should not matter at all. So how can we fix this and prevent it from happening in the future? Luckily for us, most Nest.js modules in the ecosystem expose additional static methods with the async suffix, which can help us solve this exact problem. In this particular case, TypeORM module has a for_root async method, which we can use to asynchronously load the configuration options. There are several different ways to deal with async configuration, but we will focus on the most common one, which is asynchronous factories. You can check out the other options in the official documentation. First, let's change the for_root method we are using on the TypeORM module and use the for_root async method instead. Now, let's update the input argument and use the factory function. Our factory behaves like any other asynchronous provider we've learned about in the dependency injection related videos. It can be async and it's able to inject dependencies through the inject property. So in our example, we could even inject the config service and use it here instead of using process_env directly. And that's all the changes we needed to make. Let's save everything and open up our terminal again. Great! It looks like the application bootstraps successfully now. Our code works because the asynchronous configuration we added will be loaded after every module registered in the application is resolved. Thus, the imports order won't affect anything for our TypeORM module anymore.